All right, so before we finish the notes today, let's do this little warm up here, because you'll have two questions on your quiz on Monday when we take our quiz. One question will be um, a proof using the composite identities, and then another one will be something like this where you're condensing. So first of all, is it going to condense down to a sign identity or a cosine identity? It's got to be a sign identity because why, Brady? Yeah, we have one of each in each term, right? So that has to be signed. Now, it's not quite like how we like it, right? We want the positive term, if there is a negative term, to be first. So let's rewrite it. Sine of 4x, cosine of 5x, oops, 5x, minus, and now the way that I told you, I also like the sine function first. So I'm going to commute these two factors and write that as sine of 5x, cosine of 4x. I like to keep the trig functions in order, sine, cosine, and then the first angle goes first on the first one, and then we switch it around on the second one. How do they flip? Well, multiplication is commutative, so A times B is the same as B times A.
Wait, did you not have to factor out?
No, you don't. Hi.
Hi.
Thank you. You don't have to factor out the negative if you just commute the terms. Okay? If you do factor out the negative, well, you'd have a negative out front, and then you'd have to flip it around. You should get the same answer. This is the easier way to do it. Let's look at the second way that you mentioned here in just a second, since I've already gone down this avenue. Now you got sine cosine minus sine cosine. So it's going to condense down to a sine. Your two angles are 4x and 5x, and there's a sign in between them, plus or minus. Minus, okay, because it's sine, same sign. This gives you sine of 4x minus 5x, which is negative x. Now, if we wanted to get rid of that negative inside, what could I do? Forget about it or bring it out front? Bring it out front because sine is odd. And there's the best answer. Negative sine. Okay, good. So we don't even have to work it the other way. You should get the same answer. Negative sine of x. All right. Any comments or questions on that? That'll be one of your quiz questions on Monday. Kylie, you're supposed to leave here at 9:30. I got your pass, but I'm not going to walk it over to you yet. Okay, we have a quiz on Monday. In fact, let's show you this right here. Homework's due on Monday. Quiz is Monday. Two questions, one proof and one like we did on the warm up here, and then we're going to test on Wednesday, 6-1 through 6-3. Okay, Wednesday. That'll be our last test until the final. Yeah. One proof and one like the warm up we just did. Okay. Test Wednesday. Got it? Easy enough. And that'll be our last test. And then after that, we're not covering 6.4. So we're about to finish the last of the notes for the year. It's kind of sad, isn't it? Kind of sad. But Tangent's happy because he's the last thing we're going to learn, right? There are composite identities for tangent, and we're going to learn them a little bit faster than we learned the cosine ones. First of all, tangent of x plus or minus y is equivalent to sine of x plus or minus y over cosine of x plus or minus y. Is that true? Yeah. This is basically the ratio identity, right? So because we know what sine of x plus or minus y is, and we know what cosine of x plus or minus y is, we could say tangent of x plus or minus y is the sine over the cosine. And that gives us something to do because we can expand the top and we can expand the bottom. But tangent also has its own identity that's in terms of itself. And here's the other version of it. Tangent of x plus or minus y is equal to tangent of x plus or minus tangent of y over 1 minus plus, change the sign, tangent x times tangent y. And you got to memorize that, okay? You might have a proof like that. Now, here's the easy way to remember the second one. Look at the numerator right here. The numerator is almost just distributing the tangent inside, isn't it? Remember I told you can't distribute the tangent or the sine or the cosine into its own self? It almost feels like you can here. Tangent of x plus or minus tangent of y. So that's the numerator, distribute. But then there's a correction because that doesn't work. It's over 1, change the sign. In the top, you keep the sign. In the bottom, you change the sign. They're always opposite signs. And then instead of adding them in the top, you're going to do what? You multiply them. 1, change the sign. Their product. There was an alarm going off down the hall by Kilford's room all morning. I don't know if that's related. Okay, you got it? So distribute to get the numerator, and then 1, change the sign, the product of the two. Tangent x, tangent y. All right, let's try it out. Find the simplified rationalized exact value of tangent of 5 pi 12. Actually, instead of a proof, this is what you're going to have. Sorry. You're going to have 1 like the warm-up. Your quiz is going to be like 1 like the warm-up, and then 1 like this, where you're finding the exact value of something pi 12ths. Okay? No proof. No proof. No proof. Okay? That works better for y'all, I think. All right, so we're going to use it using both identities above. So first things first. I got to figure out 5 pi 12ths. I got to figure out 2 unit circle angles that either add or subtract to give me 5 pi 12ths. Who's got it? 3 pi 12ths plus 2 pi 12ths?
Isn't it 3 pi plus 2 pi?
Well, hang on. Is this working? 3 pi 12ths plus 2 pi 12ths? Is that 5 pi 12ths? Yeah. And do 3 and 12 and 2 and 12 have common factors? Yeah, so that'll work. So that simplifies down to pi fourths plus pi 6. That'll work. Good job. You could have also chosen like 8 pi 12ths minus 3 pi 12ths if you wanted to use subtraction. Yes, yes? There's lots of options. So let's come over here, and we're going to write tangent of 5 pi 12ths. And I'm going to go left to right just once here. That's tangent of pi fourths plus pi 6. All right, now write small because you're going to need space. Now let's use the sine over cosine identity, shall we? This is equal to sine of pi fourths plus pi 6 all over the cosine of pi fourths plus pi 6. So far, so good? All right, let's keep working straight down with our equal sign. Now I can expand the top using sine. That's sine of the first, cosine of the second, same sign, same sign, sine of the second, cosine of the first. All over cosine's identity, which is selfish, right? Cosine, cosine. Cosine of the first, cosine of the second. Change the sign, minus sine of the first, sine of the second. Whoo! How's that feel? Feels amazing. It's a lot of writing, but hey, at least it's easy because we know what we're doing. Now it's unit circle time, everybody. UCT, unit circle time. What's sine of pi fourths? Square root of 2 halves. What's cosine of pi 6? Square root of 3 halves. Plus, what's sine of pi 6? 1 half. What's cosine of pi fourths? Square root of 2 halves. Yippee-ki-yay! Round 2, the denominator. Cosine of pi fourths, square root of 2 halves. Cosine of pi 6, square root of 2 halves. Square root of 3 halves, sorry. Square root of 3 halves. Plus, or minus, sorry, minus. I got distracted there. Sine of pi 4, square root of 2 halves. And then sine of pi 6, 1 half. All right, now I can simplify the top. That's going to be the square root of 6 plus the square root of 2 all over 4. And I can simplify the bottom. That's the square root of 6 over minus the square root of 2 all over 4. And if I stay change flip, the 4's will divide out. And I end up with the square root of 2 plus the square root of 6 all over the square root of 6 minus the square root of 2. The 4's divide out.
So is the quiz question be tangent or is it gonna be
Tangent is a good one. You know why a tangent's a good one? Because it makes you do sine and cosine. So does that answer your question?
well, so then cosine and sine technically.
Yeah. So tangent is a good one to ask, right?
I guess it puts 2 of them in one.
Yeah. So will it be tangent?
Yeah, I guess.
I like tangent. I like tangent a lot. Okay, now we could stop here. We could stop, but you know what? We're going to keep going. Let's come up here to a new column and just rewrite it. Square root of 6 plus square root of 2 over square root of 6 minus square root of 2. Do you remember when we were doing the unit circle, how we didn't like radicals in the denominator? You remember that? Let's go ahead and just see what happens if we rationalize the denominator. That is, if we make the exponent nice, rational, or we get rid of the fractional exponents. Now, because there's two terms down there, we have to multiply by the what of the denominator? The conjugate of the denominator. Yeah, the conjugate. Now, let's see what happens in the denominator when you multiply with the conjugate. Your radicals should go away because you get a difference of squares. Square root of 6 times square root of 6 is 6. The inner and outer cancel. You get minus root 12 on the inside, plus you root 12 on the outside. Those cancel. And on the end, you get minus root 2 times root 2 is 2. So you get 6 minus 2. That's what the bottom simplifies to. Now, on the top, you have the same quantity. So you're going to have to square, multiply, double square. Square, multiply, double square. So you square the first. And to get the middle term, because they're not opposites, they're the same, they're going to double. So you're going to get square root of 12 doubled, which is plus 2 square root of 12.
Do you want us to do this in the quiz as well?
Sure. Yeah. Oh, yeah. If we do it in class, I'll expect you to do it. Yeah. Maybe. Yeah. This is a good question. And then plus 2. Y'all can do this. It's just algebra. It's just algebra. Combine like terms. Yeah. So 6 plus 2, that's 8. So we get 8 plus 2 root 12. All over 6 minus 2 is 4. Can we keep going? Can we keep simplifying? I could break up the fraction. You want to do that? I could call that 8 over 4 plus 2 root 12 over 4, which simplifies to 2 plus root 12 over 4. Now let's look off to the side here at root 12. Can't that be simplified? It's not a perfect square, but doesn't it have a perfect square factor? Yeah, over 2. Sorry, over 2. Yeah, good catch there. I just saw that. The 2/4 simplifies to 1/2. What's the simplified version of root 12? 2 square root of 3, because 12 is 4 times 3, and 4 is a perfect square. So it's 2 square root of 3. So look what we have here. We have 2 plus 2 root 3 over 2. What happens with the 2's? OMG. Was it worth rationalizing the denominator? Yes, because instead of getting this answer on the left, we ended up with 2 plus the square root of 3. That's a lot simpler. Yeah, so it was worth rationalizing. Would I expect you to do that on a quiz or a test? Abso-freaking-lutely. This is some of the best algebra that we do all year long. It's yummy. It's heartwarming, like a good casserole that your mom makes. Okay, yummy. It's good. It's just heartwarming. Feels good. It's nourishing. Yeah. This? Oh, for the proofs for tomorrow's quiz? Yeah. All right, now that's the first way to do it. We're now going to do it the other way, doing it in terms of tangent. Should we get something that's equivalent? We should. We should get something that's equivalent. Okay, so let's go ahead and do it right here while we can still see why. Kyle, you got it? Okay, so I'm still going to do it right there. So here we go. We got tangent of 5 pi 12ths is now equal to tangent of pi 4ths plus pi 6. All right, now I'm going to write the identity in terms of tangent. So first step is distribute, wink, wink, right? Distribute, wink, wink. The wink, wink means that we know that we have to divide by 1 now. What's the sign in the bottom? 1 minus, it changes from the top, and then it's their product, tangent of pi 4ths, tangent of pi 6. All right, now we evaluate this. What's tangent of pi 4th? 1. What's tangent of pi 6? No. Well, pi 6 is square root of 3 halves, 1/2. Yes? That's pi 6. Tangent is y over x. The 2's divide out. So it's 1 over the square root of 3, which when you rationalize is Square root of 3 over 3. Yeah, remember that? And then all over 1 minus tangent of pi fourths is 1 times square root of 3 over 3. So I end up with 1 plus the square root of 3 over 3 all over 1 minus the square root of 3 over 3. Now, I have a complex fraction, don't I? How do I get rid of this complex fraction? Multiply by what? No, I can't do state change flip because the denominator is 2 terms. They are conjugates of each other, but I'm not ready to rationalize the denominator yet. You want to get rid of the complex fraction. Remember what we said earlier. If you get a complex fraction, you rejoice because the next step is to eradicate it, always. What's the LCM of your miniature denominators? 3. You got to multiply by 3 over 3. Because there's 2 terms in the denominator, you can't do state change flip. Now we're going to distribute. We're going to distribute, and that'll give us 3 plus square root of 3 over 3 minus the square root of 3. Yes, yes? Okay. Now that could be a final stopping point, but because there's a radical in the bottom, let us get rid of it now by multiplying by the what over the what? The conjugate of the denominator, 3 plus root 3 over 3 plus root 3. All right, now let's see what we get in the denominator. We'll do that first. By design, we get 3 times 3 is 9, minus root 3 times root 3 is 3. We get 9 minus 3, because the inner and outer cancel. 3 root 3 minus 3 root 3, they're gone. And in the top, we get square multiply double square. So we get 9 plus 6 root 3 plus 3. Square multiply double square. Square multiply double square. And now we combine like terms. 9 plus 3 is 12, so we get 12 plus 6 square root of 3. All over 9 minus 3 is 6. Now we can do the same thing that Peyton suggested on the other one. Let's split it up. That's 12 over 6.
Do we have to split it up, or can you divide it?
You could just divide it out. That's fine. Yeah. If you're that savvy, you could do that. Because when you divide it out this time, the fraction goes away. What's 12 divided by 6? Yeah, you're doing 6 divided by 6. You were one step ahead of me. We get 2 plus the square root of 3. Is that the same answer? Yeah. Which method is correct? Both. Which method is easier?
The right side.
I think the right side's easier. Yeah, it's fewer steps for sure. Less to keep track of. But they both involve, the one on the right involves the complex fraction. The one on the left does too, but it's a state change flip. We couldn't do state change flip on the right. We had to do lick'em over lick'em. But yeah, do I expect you to know how to do both of those? Yes, absolutely. Okay.
Are you gonna have us do?
Both ways?
Yeah, on the quiz.
I may have you do it in terms of sine and cosine only. Yeah, I may have you choose, actually. That might work. I may have you choose. So one like example 7, very, very important. Anyone watch hockey? Are the Dallas Stars still in it? I don't know.
NHL hockey team.
I think so. Yeah.
Because I watched the Corpus Christi Ice Rays one time.
Oh, yeah. They're like junior league. Yeah. I never got into hockey. Just never did. I don't know. I watch it and I lose track of where the puck is all the time. I'm like, who's got the puck? Yeah, the fights are good. That was a good fight the other day. I saw on Sports Center. They showed that. All right, example 8. Prove the following identities. So draw a line down the middle. Draw a line down the middle. What side do you want to start on? The left side, because I can expand it, right? Now, do I want to use the sine over cosine identity to expand it, or the one that's in terms of tangent? Why? Because the right side has tangent, I'm going to use the tangent identity, not the sine or cosine identity. So here we go. We distribute, right? Wink, wink. Tangent of theta plus tangent. Oops, I must have misspelled tangent. Tangent of pi fourths. Wink, wink. And then it's all over 1 minus tangent of theta times tangent of pi fourths. Now I can simplify because I know tangent of pi fourths is what? 1. So I get tangent of theta plus 1 all over 1 minus tangent of theta times 1. Is that the right side? Oh, it's so close. All I got to do is do what in the numerator? Switch them around, which is the commutative property of addition. 1 plus tangent of theta, and in the bottom, anything times 1 is itself, so I get 1 minus tangent of theta, and then it's sphere of the horn. Sphere of the horn. Yeah, so that wasn't that bad. You might prefer that on the quiz instead of tangent of 5 pi 12ths or something. But you'll get a chance to show up with these kind of proofs on your test next Wednesday on part 2. What do I do with that? Well, I evaluate it. What is tangent of pi fourths from a unit circle? It's just 1. So I replace tangent of pi fourths with 1. Yeah. And then it works out. All right, let's look at this. Let's look at this fella. Whoa, fella. That's an identity. We have to prove it. What side do you want to start on? The left side. Kylie, are you texting someone the results of the previous problem? You get to leave at 1. You get to leave at 9:30, and then you can use your phone. Okay. What side should we start on, Kylie? What side would you start on? I would start on the left side as well. Why? There is more, right? We have 2 terms instead of 1 term, and we also have this. We have the invitation to expand that. Now notice the right side is in terms of single angles x and y. The left side is in terms of compound angles x and y plus or minus. We have a way to expand the compound angles to get single angles. It's rarely hard to take a single angle and build it up into a composite angle. Okay, compound composite, the same thing. So let's go ahead and expand the left side. Here we go. Sine of x minus y, that's sine of x, cosine y, minus sine of y, cosine x. All right, and then we have plus the next one, sine of x, cosine y, plus sine of y, cosine x. You have to start sufficiently to the left, don't you? Or move things over. Okay, now we can combine like terms. Hey, holy moly smokers, what do you notice about the 2 middle terms? They subtract out, and we're left with just sine x cosine y plus sine y cosine x. Do those cancel out? Are those the same? No, they don't. They look like they should cancel out. Do we have any like terms, though? Minus sine y cosine x plus sine y cosine x. There you go. Those are the ones that cancel out. Got to be careful here. They all look the same. And then I have the sine x cosine y plus another sine x cosine y. What's one of those plus one of those? 2 of those. 2 sine x cosine y's. Compared to the right-hand side, how are we done? Fear the factor horn, baby. The effing horn, the factoring horn. Yeah, fear the factoring horn, or just fear the effing horn for short. Yeah. I get to teach middle schoolers this summer, 8th graders. Yeah, I volunteered to do that just to sharpen my game up a little bit, just because it's been a while since I've taught kids that young. Algebra, well, pre-algebra, 8th grade math, pre-algebra. I'm there. These are the kids. These are the kids that need extra help to get ready for algebra 1. Yeah, so for 4 weeks, 4 days a week, 4 hours a day. Yeah, and I'm just thinking if I do something like that kind of humor with them, like fear the effing horn, fear the factoring horn, I'm gonna lose them. Like they're gonna giggle the rest of the day. Like he said effing horn, he said effing horn, he said factoring, but I know what he means. Hey mom, dad, guess what? So I gotta really like dial it back a little bit. I was talking to a lady yesterday who gave me the curriculum, and she says if they get bored, you could just take them outside. It's going to be at Oakland Middle School. And I was like, oh, yeah, aren't there some woods over there at Oakland Middle School? We could just take a little hike through the woods. They're going to get some fresh air. And she goes, no, you don't want to take 8th graders into the woods. And I'm like, okay, I guess I won't then. I don't know. Yeah, you can set it over there. Thank you. What would eighth graders do in the woods if I took them there? Reproduce? I don't know what she meant. I don't know what she meant. But see, I have to really. That's why I'm teaching it. I gotta remember how eighth graders work. Right? They're all awkward and young and pubescent and prepubescent all mixed together. Right? It's gonna. Yeah. I don't know if y'all can remember back to eighth grade. Right? I'll be dealing with those people.
You're gonna be bored, Mr. Worthy.
Am I gonna be bored?
I think so.
I think so too.
Yeah, getting used to PC calculus.
I think I will be bored, but I can do it. I could do it. I'll have to make new jokes. Can't use the same level of humor. I have to really come down to their level. Like say the word booger or something. Booger. He said booger. All right, let's prove this one. Last one. Last new question of the year. Okay. We draw a line down the middle. What side do you want to start on? Left or right?
Right.
Okay, now if we start on the right, notice we have angles that are different. And on the left, we have a 3u. Your first goal is to get the angles the same. If your angles are not the same, then you can't really use the identities to match one with the other. They have to be the same. So my question to you, is it easier on the right to build up an angle of u into a triple angle 3u, or would it be easier to tear down the nucleus angle, that is the big angle 3u, into something smaller? Tear down. So even though there's more terms on the right, this new first goal, which is to get the angles the same, kind of trumps the right side has more terms and it has more trig functions, so it looks like it has more information. This goal of getting the angles the same kind of trumps that, and we're like, it's a bigger angle, it's easier to tear it down. So I don't have a triple angle identity, so what I'm going to do is I'm just going to call 3u 2u plus 1u. Is that okay? Now, do I want to call it 4u minus 1u? No, because I don't want to start introducing bigger numbers. I don't want to say it's a 100u minus 97u. Heck no, that would be correct, but that's getting bigger numbers. I'm trying to express it in terms of smaller numbers. 6 minutes, Kylie, and you can go. So now I can expand this out. This is sine of 2u, cosine of u, plus sine of u, cosine of 2u. Now that's a step in the right direction because I have single u's, but notice I still have two u's or double u's. So what I need to do now is break those down. So watch this. I'm going to call this, stupid highlighter, I'm going to call sine of 2u, I'm going to call that sine of u plus u, times the cosine of u that's there, plus the sine of u that's here, times, I'm going to call cosine of 2u, I'm going to call it cosine of u plus u. I made progress in the first step, but I still have more progress to go, okay? Now here we go. We're going to expand it out. Sine of u plus u is sine of the first, cosine of the second, sine, sine of the second, cosine of the first. Now you got to be careful because that's two terms. It's still all times cosine of u. Plus sine of u times parentheses. Okay, we might need to move this over a little bit. I need more room here. That's a good thing about notability. We can just move it over. All right, and then cosine of u, that's cosine of the first, cosine of the second. Change signs, sine of the first, sine of the second. Now, notice in the blue parentheses, because the angles were the same, I have sine u cosine u plus sine u cosine u. That turns into sine of, that changes into the sine 2 sine of u cosine u. 2 sine of u cosine u. So it goes back to one term, times cosine of u, and then plus sine of u. Notice the cosine of u becomes cosine squared of u minus sine squared of u. No, it's not 1 because it's minus. If they were both positive, it would be 1. If they were both negative, it would be negative 1, but one's positive, one's negative. Now, what we just did, guys, we just derived what the next section would be about if we were to cover it. It's about the double angle identities, and I would have you memorize the results. Sine of 2u is equal to 2 sine of u cosine u, and cosine of 2u is equal to cosine squared minus sine squared. That would be the next set of identities that we would cover if we were to go into the next section. Those show up a little bit in calculus, but I'll just throw those at you again if you ever take calculus. You don't have to memorize those, okay? But those are called the double angle identities. Sine of 2u is 2 sine u cosine u, and cosine of 2u is cosine squared minus sine squared. So now at least you could say you saw them. All right, now let's look at the right-hand side. The right side is completely expanded out, isn't it? So let's go ahead and do that. I'm going to now combine these right here, and this gives me 2 sine of u cosine squared of u. And then if I distribute the sine of u, I get sine of u cosine squared of u minus sine cubed of u. How's that looking? Is that the right-hand side? It's close. Now look what we have. We have 2 sine u cosine squared plus 1 sine u cosine squared. Aren't those like terms? Yeah, so now 2 of them plus 1 of them makes 3 of them. So I have 3. Now notice instead of writing it as sine u cosine squared, the right side has the cosine first. So I'm going to commute those two factors. That's legal. 3 cosine squared of u, sine of u, and then minus sine cubed of u. Did I get it? Did I do it? Fear the booger horn. He said booger again. It doesn't even make sense. But I like it. Fear the booger horn. Booger. And that's it. That was the last question of the year. Right? We're not doing 6.4. No, 6.4, we just did 6.4. Sine of 2u is 2 sine u cosine u, and cosine of 2u is cosine squared minus sine squared. That's 6.4. We just kind of did it in this example. I don't even keep track of them because it would make me too sad. Okay, we're done with the notes. Any questions? How'd you like pre-calculus? Did you like it? It's over. Now it's just review and test for the final. Well, we got to test over this stuff too. But that's it. That's all pre-cal. Congratulations. You survived.